Alright, you guys, find a polynomial of degree 3 whose zeros are -3, 2, and 5. Let's do part A first. If r is a real zero of a polynomial f, then x minus r, I'll write this down. If r is a zero, then x minus r is a factor. Because obviously if you set x minus r equal to 0, x equals r. Okay? This means that x minus -3, which is the same as x plus 3. Also, x minus 2 and x minus 5 are all factors. Okay? So, I can make this, let's see here. I know it has degree 3, so it could be multiplied by some number out in front, but essentially, these are the factors. Oh dear. There we go. Okay. Alright, then it says use a graphing utility to graph the polynomial found in part A. I trust that you guys are all able to FOIL, so I'm just going to tell you what this FOILs out to be. Let's see here. Without the A, it turns out like this. And the A just has the ability to stretch or compress it depending on what it is. Okay? If you graph it, you guys all have graphing calculators. It looks something like this. Alright, this really isn't such a great sketch, but on your calculators, hopefully you can see that it hits at -3, 2, and 5. Now this graph, the 2 and the 5 look too close together, but -3, 2, and 5 are the zeros, so that's where the graph hits the x-axis. Alright, I'll let you guys try the u-try. Alright, 0 multiplicity m of f. Let me write out the definition. If x minus r to the m power is a factor of a polynomial f, and x minus r to the m plus 1 power is not a factor, then r is called the 0 multiplicity m of f. Okay? So, for example, for the polynomial, as shown, 2, let's see here. 2, because of this factor here, is a 0 of multiplicity 1, because it's to the 1 power. Okay? -3 is a 0 of multiplicity 2. Alright, and 1/2 is a 0 of multiplicity 4. Should be pretty easy. It's just whatever the power is for that particular 0. I'll let you guys try the u-try problem. Okay, example 6. For the polynomial f of x equals x squared times x minus 2, find the x and y-intercepts first. Okay, so you guys hopefully remember from Algebra 1 the way you find x and y-intercepts is just to plug in 0. So where's my cursor here? There it is. Sorry, my tablet seems to be malfunctioning a little bit today. Not sure why. Alright. And let me pause the video, figure out what's going on. Alright. Seems to be working a little better now, I think. Hey, whoops. Never mind, let me pause the video again. Alright, there we go. Okay, X-intercepts. What I'm going to do is I'm going to set the equation equal to 0 and solve for x. So in here, x squared equals 0, x minus 2 equals 0, so x equals 0 and x equals 2. Those are the x-intercepts. To solve for the y-intercepts, I'm just going to plug in 0 for x. So y equals 0 squared. Come on, there we go. 0 minus 2. Sometimes if you see the cursor freeze, it's because my tablet's being temperamental today. So 0 times negative 2, 0. So the x and y intercepts are, I'll just write them out, 0, 0. Come on, there we go. 0, 0, and 0, 2. Sorry, wrong way. 2, 0. Okay. Using a graphing utility, graph the polynomial. I think I'm pretty confident that all you guys know how to graph on a graphing utility. Okay. For each x-intercept, decide whether it is an odd or even multiple. Okay. So, let me just draw a quick sketch of what the graph looks like. Alright, the graph looks something like this. Come on, where's the cursor? There it is. Okay, it hits at 0, 0, and then also at 2, 0. This point, 0, is derived from the x squared, so it has a multiplicity of 2. So, 0 is of even multiplicity. And 2, because it's only to the power of 1, is of odd multiplicity. Okay? So this is part C. Alright, I'll let you guys do this one. Let's go on to example 7. Or actually, we've got some definitions. Okay. Even multiplicity and odd multiplicity. Alright. If r is of 0 multiplicity, then you're going to see the graph just touch the x-axis at r. If r is of odd multiplicity, you're going to see the graph cross. So for example, up here, 0 was of even multiplicity. That's why the graph just touches at 0, 0 and then comes back. 2 is of odd multiplicity. That's why it completely crosses the x-axis. Okay, so that's another way you can tell. If you don't have the equation, if you only have the graph, that's one way to know. Alright, turning points. Alright, if f is a polynomial function of degree n, then f has at most, where's my cursor? Hey. There it is. Okay, if f is a polynomial function of degree n, then f has at most n minus 1 turning points. If the graph of a polynomial function f has n minus 1 turning points, then the degree of f is at least n. So the converse is also true. Okay? So let's do an example. Example 7. Which of the graphs below could be the graph of the polynomial function? Alright, so I did not put the graphs here. I'm going to draw them in for you. Alright, let me change colors here. Go back to blue. Okay, so this one could not be a polynomial because it's discontinuous here. I think this is a -1. Okay? This one, it could be a polynomial, and it has 3 real zeros at -2, 1, and 2. I write that down. Okay? The graph has 2 turning points. Here, it turns, and then here, it turns. Okay? So, the polynomial function must be at least degree 3. Okay? Actually, I'm going to write it this way. Okay? Alright, let's take a look at C and D. I'll scroll down. Okay. This function cannot be a polynomial because it has a cusp. okay, at, I think this is at 1, okay? Because it has this sharp point, this cusp, it can't be a polynomial. But D, this one could be a polynomial. It has 2 real zeros at -2 and at 1. The graph has 3 turning points. 1, 2, 3. So the degree of the polynomial must be at least 4. Okay? Alright, and I'll save the rest for the next video.